In problem number 11, 1.11, 1.11, he asked to find gradient. I hope that would be not a big deal, okay? Finding the gradient of each of these functions. So we shall do this problem number 1.12. So 12, so problem number 12. 1.12. H of x comma y, h of x comma y is equal to 10 2xy, 10 into 2xy minus 3x square, 4y square minus 18x plus 28y minus 18x plus 28y plus 12 is equal to plus 12. Am I right? Plus 12. Height, obviously, it's a function of x and y. Am I right? At different point, our hill have got different height. Now, so what is the question? Part A of the question. Where is the top of the hill located? How do you write? Where is the top of the hill located? Again, I think you haven't read that one, these comments. He said that one. Gradient equal to 0 at the top of the hill. At the maximum, gradient will be 0 usually. It's a kind of, again, our derivative equal to 0. So can you just write the comment note? You better take this note, because I haven't interpreted this one. Del t is equal to 0 at some point. 0 means null vector, okay? At some point is equivalent to dt is equal to 0 for small displacement around that point. Am I right? Can I say like that? Because dt is written as del t dot df, isn't it? When that would happen? At maxima or at minima that would happen usually. Is that okay? So again, or you can just write, look at here, dt by dl vector, mod dl vector, that's equal to del t cos theta. Am I right? If del t equal to 0, a change in dt by dl is 0. The same sentence. Am I right? For a small displacement, dt equal to 0 means dt by dl equal to 0. When there is a change in dl, dt equal to 0. When the del t equal to 0, at the point where del t equal to 0, at the point where gradient equal to 0. So there is either a point of maxima or point of minima, isn't it? So our derivative vanishes at point of maxima or minima. Now the situation is you can displace in any direction. In single variable calculus, we have only two ways. Am I right? So now from the top of the hill, you can displace in any direction. So that's why this dl vector can point in any direction at the top of the hill. You can displace in any direction. So change in dt is equal to 0. So since del t is equal to 0. Okay. So now the next one is, so that's why, so del t, so that is equivalent to, so you better write one sentence. The points at which del t is equal to 0 are called as stationary point. Either maxima, minima or saddle point. right? Either maxima or minima or saddle point. Maxima, minima or saddle point. Yeah, that's correct. I mean, again, yeah, we shall try to solve this. At the maxima, minima or saddle point, when you displace in any direction, usually change in that quantity is almost zero. Is that okay? So that's why the derivative, we say the derivative is zero. Is that okay? So now look at here. Again, what is that one? First idea. So del of h, that should be equal to 0. Am I right? This will give two conditions. Why? That's a vector. Vector is 0 only when its components are 0. And you will have two equations, two unknown, obviously, x and y, isn't it? So have you found that one? Yeah. So what is this one? X cap into dou h by dou x plus y cap into dou h by dou y is equal to 0. I need to find the point where gradient vanishes, okay? So that is the topmost point. So if you take a hill, there is no minima actually, only topmost point, okay? You don't have to think about whether it is topmost point or I mean maxima or minima, okay? So now look at here, dou h by dou x should be 0 and dou h by dou y should be 0. A vector is 0 means its components are 0, isn't it? So now you got two equations, two unknown. You can find x equal to something. So let me say x naught, y naught is equal to something, am I right? So you found that one. What are the values? X equal to -2, 3. So now the next part of the question is, how high the hill? We substitute. Now I got one problem. If you put x equal to 0, y equal to 0, what would you get? No, you will get some height, am I right? Obviously. So, yeah, that's not the point. That's correct. You have to put x naught and y naught, am I right? So, hill is like this now. I mean, it need not be centered at the origin, okay? So, somewhere else. So, hill is like this, x cap, y cap, z cap, isn't it? So, now if you put x naught and y naught, you will get, I think, the location of that one, h of x naught and y naught. Yeah, speak up. 11, 720 meter feet, 720 feet, 720 feet. Now, he asks one more question. How steep is the slope at the point 1 mile north and 1 mile east of south? 1 mile north, 1 mile east. He is talking about x and y points, but he is writing in mile. You are saying in feet. What would you do? No, the x and y are in miles. This should be mile, isn't it? X and y are in miles. So just check it out, the question. Miles. Is that okay? Everything should be in miles. Yeah. You substituted this one, am I right? Now why would you worry? No, don't, yeah, you have solution manual. Can you just open? Just cross check that one. Yeah, why would you worry? I mean, he has given in miles, am I right? So now look at here, which one you are going to take north? Look at here, he has written in the question itself, y distance north, x distance is east of south Hadley. And he has given, you have to find the magnitude of the gradient at that point of x and y, isn't it? Read the question carefully. Read the question carefully. In the question, he said, y is the distance north, x is the distance east of south. I mean, one is, both are perpendicular, am I right? So, both are perpendicular. How steep the slope at point 1 mile north and 1 mile east? That means x equal to 1 mile, y equal to 1 mile, y equal to 1 mile. You have to find gradient of t, mod of gradient of t at 1 comma 1, isn't it? Feet. Answer is in feet, but question is in miles. Look at that one. Huh? Feet per mile. What do you mean by feet per mile? Okay, hills in feet. X and y distance in miles. Then it makes no sense. Yeah. Speak out. Height in you have to convert. That's what he is expecting. No, then no. He is saying in the next part, y is the distance in miles. If y is the distance in miles, how height will be in feet? Wait a second. Y is the distance in mile, but in your equation you have both x and y. Am I right? Both are distance. Am I right? X and y both are distance. Why he put that confusion? Wait a second. So I have one more point here. Part C of the question. Look at the part C of the question. Okay, just forget. So just take everything in feet or miles, whatever. Okay. So maybe so we may not able to understand him. Okay. So maybe he is right because he has given only x in miles. He hasn't given what is y, isn't it? X and y are in miles. Then how height will be in feet? Isn't it? You in your equation you have y, x, these linear terms. Am I right? Feet per mile. Yeah, that's correct. Okay, good. He is measuring. So this one in feet, these two are in miles. That's correct. Is that okay? X and y are in miles, measuring height in feet. So, yeah, then that's correct. Because all three are different axes. Am I right? That's your choice. And again, our convenience also, isn't it? This is now miles or feet. You can just do and you can substitute now. Is that okay? You can just do and you can substitute. All three are independent variable. H, x, y, isn't it? H you are going to draw along z axis, isn't it? You can call it, whatever you put. So take x and y in miles, h is in feet only. That's how it is designed. The equation is designed. Is that okay? No need to worry. Okay? X and y in miles, height is in feet. Okay? That's correct. So 720, if you substitute these two in miles, you'll get 720 feet. That's correct. But I have one more question. He said find gradient of t at 1, 1. Am I right? Or no, he hasn't said gradient of t. What he said, look at that one. How steep the slope, isn't it? That means he is asking, at 1, 1, you got various direction. In different direction, you have different slope, isn't it? Are you getting my point? Part C of the question. See that one carefully. How steep the slope at 1, 1? Now my question is, in what direction you are asking the slope? Are you getting my point? Because it's more than one dimension now, isn't it? That's why if you talk about slope of the hill, am I right? So from any point, you got different choice of moving, am I right? You can move like this, you can move like this, you can move like this, isn't it? At different direction, you will have a different slope that he didn't mention. What he has taken in answer? Okay. No, that's okay. That's a gradient direction, isn't it? At any point, from any point, in the gradient direction, slope will be steepest. Because in that direction, so change in that height is the maximum one, am I right? Height. Isn't it? In that direction, change in the height is the maximum. That's okay. You can take the gradient, you can make it as a unit vector. You have to make it as a unit vector, okay? So don't keep that vector as it is, because when you are talking only about direction, make it as a unit vector, okay? Don't keep its magnitude other than unity. So now, but the first part of the question is, how steep the slope at 1, 1? Yeah, what he has done? Northwest. He has taken direction. He has taken directional derivative. Directional derivative. In which direction? X cap plus y cap by root 2. X cap plus y cap by root 2. X and y value. No, so he has taken directional derivative with x cap plus y cap by root 2. No, that's I don't take this one. Why? He has calculated magnitude of this one, but magnitude of this one is the maximum rate of change. Am I right? Are you getting my point? So from this one, if you want to, if you are asking about the derivative, if you are asking about the slope, isn't it? In which direction you are talking about the slope? Isn't it? In the different direction, you have different slope. So next part is okay. What is the next part? In which direction the slope is steepest or slope is maximum? So in the direction of the gradient, slope is maximum. Is that okay? So find the gradient at that point. So find the gradient at that point, make it as a unit vector. That is the direction where the slope is steepest. Okay, the question should be modified. Part C of the question, you better to say, what is the maximum, what is the slope in the maximum steepest direction, like that, okay? What is the maximum change in the, not like that. What is the maximum slope? That's enough, am I right? So what is the maximum slope at this point? So modulus of gradient, that's the maximum rate of change, isn't it? That's the maximum slope, okay? And if you make a unit vector out of that one, that would be, direction in the maximum change, okay? Be careful, at any point, if you are talking about slope, now it's more than single variable, you have to talk about the direction, am I right? Yeah. Yeah, what was this answer actually? No, I mean not mod. Let me give me del h at 1, 1. I mean vector, I need a vector. 221. So 220 into minus x cap plus y cap, isn't it? Minus x cap means x was distance in north, minus x means its distance in south. Am I right? If you make it unit vector, by root 2 will come, obviously, isn't it? What's a unit vector along this direction? So that's a minus x cap plus y cap divided by root 2, isn't it? So now obviously this the direction, suppose if you just plot x and y axis, suppose if you plot x axis, y axis, so what is this direction? Minus x, this direction. He said this is north, this is south Hadley. So why he put that word Hadley? Okay, south, no, that's not. Okay, this is north, then this is east, x is east, yeah, x is east of south, he said like that, whatever, yeah, whatever. Then so obviously your unit vector is along this direction, am I right? Then that is north, northwest, that's the answer, northwest, am I right? If this is the east, this is the west, that is northwest. That's how you have to judge. Is that okay? Yeah, try to do the whole problem again. So now let me quickly just explain how to solve next problem, okay? Try it yourself. So del of italic r square. What is your italic r? Or italic r magnitude, x minus x prime root of, what is italic r? I hope you know that idea. Origin r prime, r vector. So from source to field point, that's your italic r, am I right? X comma y comma z, x prime comma y prime comma z prime. Is that okay? So now italic r is equal to root of x minus x prime the whole square plus y minus y prime the whole square plus z minus z prime the whole square. Now look at here, if I write it like this, so del of r square, obviously r square is just take off the root, that's it, isn't it? Now I haven't mentioned any prime here, that's why you have to take derivative with respect to unprimed one. That means, so my del operator, so that's equal to x cap dou by dou x plus y cap dou by dou y plus z cap dou by dou z. So later in the polarizations chapter we are going to define this one. Then that is dou by dou x dash, dou by dou y dash, dou by dou z dash. Okay, but here, so he didn't mention any prime here. Okay, don't take unnecessarily or don't get into the confusion that in which with respect to what you have to take derivative. Am I right? You have two variables, isn't it? So in this case, x, y, z are variable. Treat them x, y, z are variable and just do that. Is that okay? Obviously, you will get similar result as earlier. Do all of those three problems. Is it clear? So del r square is x cap into dou by dou x of r square plus y cap into dou by dou x of r square plus z cap into dou by dou x of r square. Now dou by, but what did I said? Dou by dou z. Now, so similarly, after doing all of this, so do this one, del prime of r square. So do all of those del prime. So that will come in the later chapter. Is that okay? Del prime of r square, that means derivative with respect to x prime. You may get one more negative sign because look at here while taking the derivative. Okay, you may get one more negative sign. Do that one also. Okay, so del means unprimed, derivative with respect to unprimed coordinate. Del prime means derivative with respect to primed coordinate. Just remember like that. Okay, so those are very different. Okay, One is a source point, isn't it? This is your source point. Taking derivative with respect to source point is different. Taking derivative with respect to, this is the field point. This is the field point. This is the field point. This is the source point. Taking derivative with respect to field point is very much different from taking derivative with respect to source point. Okay. If you take derivative with respect to source point, you are talking about some property of that source. That is again we shall study in electric fields in matter. Okay. So now, yeah. So now again first two chapters. So 2 to 3 chapter up to 3rd chapter, we are talking about derivative with respect to source point only. Is that okay? Only when we talk about polarization and all, we will talk about derivative with respect to, again what did I say? What did I say? Derivative with respect to field point. Is that okay? This is derivative with respect to, write down. Derivatives with respect to field point. Up to 3rd chapter, 2nd and 3rd chapter, we will talk about derivative with respect to field point. Is that okay? We will take field is created by some source. We will not talk about source. Okay? Only in I think 4th chapter. Am I right? In the 4th chapter, we will get into how those are created. We will get into matter. Derivative with respect to field point. Again, along with this one, define this one also. What is this one? X cap dou by dou x prime. I think you don't have to put prime here, okay? Because once you choose origin, that x cap, y cap, z cap will not change, okay? That's your choice here. So now, plus y cap dou by dou y prime plus z cap dou by dou z prime, derivative with respect to source point. Okay, in chapter 2 and chapter 2 and 3, we will talk about this one. Okay, we will never talk about this one.